Today I'll discuss how to find the inverse of a function. An invertible function is one whose inverse exists if and only if the function is bijective. What do we mean by bijective? When we say the function is bijective, it is both one-to-one and onto. Another term for one-to-one is injective, and another term for onto is surjective. So it means to say that if a function is both injective and surjective, then it is bijective, and hence it is both one-to-one and onto. But how do we know whether a function is one-to-one? Say we have a function f, which is a mapping from A to B. A is the domain, and B is the codomain of the function. So this function is defined by, in general, y equals f of x. We say that f is one-to-one, or that is injective. Okay. If for every AB in the domain of the function, f of A equals f of B, then A equals B. For example, you have a linear function, f of x equals, let's just take 5x minus 2. When we want to show that this is a one-to-one function, then we just have to take two randomly selected numbers from each domain, say A and B. So A and B are both in the domain, of f of the function. Okay, so we have this f of A equals f of B must imply A equals B. Okay, so f of A equate to f of B. Alright, so what is f of A? We simply change A in this expression. Okay, change x to A in that expression. So that's going to give us 5a minus 2. And then equate that to f of B. So for f of B, we have to change all x in 5x minus 2 to B. So that's 5b minus 2. Now, this must imply A equals B by manipulating the equation. Okay, so obviously we have negative 2 on both sides of the equation. So if we transpose 1 negative 2, then this would be equal to 0. And so we'll just have 5a equals 5b. And then dividing both sides of the equation by 5, we'll simply get a equals b. Alright, so that's it. Now we conclude that f of x equals 5x minus 2 is one-to-one. Now, it's harder to show that a function is onto, but it's somehow like this in the figure. Say, for example, you have a domain and codomain of the function, and in the domain, let's say we have A, B, and C, and in the codomain we have 1, 2, 3. And let's say that the function maps A to 2, and then B to 3, and C to 1. So this is our function f. Now this function f is both one-to-one and onto. This is one-to-one because each element in A maps onto one and only one element of B. So we'll have the ordered pairs. So A goes to 2, and then b goes to 3, and then c goes to 1. Okay. So again, each element of A goes to exactly one element of B. That's why the function f is 1 to 1. Now what is the range? Range of the function. The range of the function contains the numbers 2, 3, 1. Now as you can see, this is also the codomain, the elements of the codomain. So if the range and the codomain are the same, then the function must be on 2. That's very easy to identify when we have a definite number of elements in the codomain. But what if there's an infinitely many number of elements in the codomain? How do I identify whether the function is on 2? So again, let f be a mapping from A to B. So it is defined by generally y equals f of x. So we say a function f is on 2 if for every y in the codomain of the function, there is x in the domain such that we satisfy this. So to say that a function is on 2, we have to make sure that every, look at this, in this codomain, okay, we have to make sure that every element in the codomain is an image of the elements in the domain. Or we can just say that every element in the codomain is being used in the function, just like in this given function. So if ever one of the three numbers in 1, 2, 3 is not used in the function, then we cannot say that the function is on 2. Say for example, this function y equals x over x minus 1. Now assuming that this function is a mapping from the set of real numbers to the set of real numbers, meaning the domain is the set of the real numbers and the codomain is the set of real numbers also. Or we can exclude 1 from the domain. Obviously, it's not included in the domain. Now remember that the codomain is different from the range. Now solving for x or writing x in terms of y, okay, we have to multiply both sides of the equation by x minus 1. So on the left side, we'll have multiplying x minus 1 by y, we'll have xy minus y equals, of course, on the right side, we'll just have x. So we have to write x in terms of y, therefore we need to combine all terms with x. So transposing terms, we'll have xy minus x equals y. And then factoring x on the left side, we'll get x times the quantity y minus 1 equals y. And then dividing both sides of the equation by y minus 1 to finally isolate x on the left side. So x in terms of y equals y minus 1. So as we can see, y cannot be equal to 1. So therefore, y is not an image of any element of the domain. Okay, it means to say that you cannot choose any number in the domain to substitute for x in your function, in this function, okay, such that the value of y will be equal to 1. So therefore, 1 is in the codomain, but 1 will not be in the range of the function. Therefore, the function is not on 2. So enough with one-to-one and onto function. We'll just have to assume that all given functions from now on are both 1-to-1 and onto. And onto. Right? So if we are to assume that way, then we can also assume that all given functions are already invertible. Meaning we can find the inverse of the function. Anyway, we can make a function both 1-to-1 and onto by changing or manipulating their domain and range. Okay? So let's have an example. Let's find the inverse of the following functions that I'll give you. Let's take a simple function. A linear function is always both 1-to-1 and onto. So let's just take y equals 3x minus 4. So the first step of the solution would require us to change all x to y and then vice versa. So change x to y and then y to x. So the equation will now be in this form. X equals 3y minus 4. And then finally, we write y in terms of x. So transposing negative 4 to the left, you'll get x plus 4 equals 3y. And dividing both sides of the equation by 3, we'll get y equals x plus 4 over 3. This is the inverse of the function, but how do we denote the inverse? Well, it depends on how the function was written. So the inverse can be denoted by this. F raised to negative 1. Okay, this is it. In our first example, we have just written the function as y equals 3x minus 4, so the inverse can be written in this way. This is our inverse. So let's have another example. This time f of x, use another notation, is equal to x over x plus 2. Okay, this function is 1-to-1. Okay, so if we do not change its codomain to the set from the set of real numbers to another set, then this function will not be onto. Okay, but changing the assuming that we change the codomain of the function, then this function in number 2 will now be bijective and therefore invertible. So we can find its inverse. Okay, since the function is written in the using the notation f of x, we need to write the function as y equals x plus x over x plus 2, because remember we have to change all x to y and then change y to x. Okay, so the next step would be changing y to x, okay, and then x to y over y plus 2, and then solve for y in terms of x. Okay, to simplify it, to do that, we multiply both sides of the equation by y plus 2. And then assuming that you know how to multiply algebraic expressions, the left side will give us xy plus 2x. And then the right side will just have y on the right side. Okay, so we need to write y in terms of x, so we need to combine all terms with y. So transposing terms, we'll get xy minus y equals negative 2x. Then factoring y from the left side expressions, y times the quantity x minus 1 equals negative 2x. And dividing both sides by x minus 1, okay, we have the inverse of the function, denoted by f raised to negative 1 of x. So this is read as inverse of f of x equals negative 2x over x minus 1. This is our final answer. One last example, given g of x equals 2x cubed minus 1. Okay, again we write the equation as y equals 2x cubed minus 1. And then write y as x and x as y. So 2y cubed minus 1. And then solve for y. Write y in terms of x. So transposing negative 1 to the left, we'll get x plus 1 equals 2y cubed. And divide both sides by 2. Alright, so now we have y cubed equals x plus 1 over 2. Isolating y on the left side, we need to get the cube root of both sides of the equation. Alright, so that's it. This is now y equals cube root of x plus 1 over 2, or in another notation, because the given is in the form g of x, we write our final answer in the form inverse of g of x equals cube root of x plus 1 over 2. This is our final answer. Now, one last thing, we will be able to identify whether a function is one-to-one through the graph, okay, using the horizontal line test. Horizontal line test. Alright. How is the horizontal line test being done? So if you have this graph of the function y equals f of x, for example, just in general form, okay, if we draw a horizontal line anywhere, okay, in the graph, like this, if the line and the graph intersects at exactly one point, just like this, it intersects here at that particular point, xy, exactly one point, then we can conclude that the function is one-to-one. Okay. Again, using the horizontal line test, if the horizontal line and the graph of the function only has one intersection point, okay, then we can conclude that the function is one-to-one. Otherwise, if we have, for example, this parabola opening upward with vertex at the origin, so drawing a horizontal line through the graph, you see they intersected at this point and also here. So you have 1, 2 points of intersection. Okay, so therefore the function is not one-to-one. So that's how you know whether a function is one-to-one using horizontal line test. See you in the next video.